So section 6 is differential equations and slope fields. If you look at the 2015, they give you the differential equation and they ask you to plot the slope field. So remember with the slope field, you're just going to take the ordered pairs, and I suggest on the exam you just list them so that way you won't get confused. And you just plug in to your derivative and get the slope, and then you'll make the slant. So at 0, -1, we've got a +1. At 1, -1, we got a +3. So see how this is steeper. And you can see, you just try to make the steepness based on the slope. So part B says find the second derivative, determine the concavity for the equation in quadrant 2. Give a reason for your answer. So you're given the first derivative. The second derivative will just be this. And remember, we'll substitute in what dy dx is. And if you simplify that down, that's your second derivative. Now think in the second quadrant, your x is negative and your y is positive. So if you just put a negative there and a positive, you see that the answer is going to have to be positive. So that means if the second derivative is positive, it's going to be concave up. And part C says let y equal f of x be the particular solution with initial condition f of 2 equal 3. Does f have a relative minimum, a relative maximum, or neither at x equal 2? So you're going to put 2 in, but remember the zeros of the first derivative are the relative max and min of your original function. So if you put 2 in the derivative, you don't get 0, you get 1. So that means it's neither. And part D says find the values constant, m and b, which y equal mx plus b. I think we've done this one before, but, and again, this is a part D. You're not going to get that many D's, but you know that 2x minus y is your m. You know y is mx plus b, so you can substitute that in. You do your algebra, set it equal to 0. You pull out your greatest common factors, x, and then think about it when you get right here. The only way this equation can equal 0 is if that equals 0 and that equals 0. So you set them equal to 0, and you get m equal 2 and b equal -2. So there was a second one on the 2015 that had to do with differential equations. So it says consider the curve with the equation here. It can be shown that the derivative is here. Write an equation for the line tangent to the curve at -1, 1. Well, you've already got your ordered pair. You just plug that in to get your slope. Use your slope in ordered pair to get your b, and you get your equation. Very straightforward. Next, part B says find the coordinates of all points on the curve which are tangent, that the point is vertical. So for it to be vertical, slope's undefined. So for the slope to be undefined, the denominator would have to equal 0. So if you do that, isolate one of the variables. I isolated x, and then come back into your original function, substitute that in so you can get down to a singular equation. So you see here we get -2y cubed equal 2, y cubed equal -1, y equal -1. Then I can come back and plug -1 in here and get my x. So the ordered pair would be 3, -1. And it says evaluate the second derivative at the point on the curve where x equal -1 and y equal 1. So first of all, you have to get the second derivative. So you're going to do quotient rule. So I'm going to do this minus this. And then I know dy dx at that point is 1/4. So instead of putting the algebra dy dx, I can just plug in 1/4 and plug in the 1 and -1s and work all that out, and you get 1/32. So just strictly doing the quotient rule and then plugging in what you know. So the 2014 gives you the derivative. Let y equal f of x be a particular solution. F of 0 equal 1 is your initial condition. And they've already got the slope field. And they say sketch the solution curve through 0, 1. So whenever you want to sketch the solution curve, you just go to the point they give you, and then you just follow your little slope fields, and then you just sketch the curve. So this is one of the solutions to the differential equation. Now part B says write an equation for the line tangent to the solution curve at point 0, 1. Use the equation to approximate 0.2. So we've got an ordered pair. We need to get our slope. So we're just going to plug 0 in and 1 in. And if we do that, cosine of 0 is 1, so your slope is 2. Just come over here and use your ordered pair and your slope. Get your linear equation and estimate what they wanted you to estimate, which was 0.2, so you get 1.4. Now, find y, the particular solution with the initial condition. So this is where we get the variables separated and integrate. So I'm going to divide this over, cosine stays there. I'm going to integrate. Now this, I'm going to come over here and do u equal 3 minus y. Du will be negative dx, so I'm going to put a negative out here, 1 of u, negative ln, 3 minus y, integral of cosine is sine. So I'm going to put that there. I divided by the negative, and then I put in my initial condition, which was f of 0 equal 1. So if I put 1 there, I get 2. Put sine of 0, I get there. Sine of 0 is 1. So negative ln of 2 equals c. So I'm going to go back and right here, I'm going to plug in minus negative ln of 2. I'm going to take the e of both sides. So this will be 3 minus y. Now remember, when I take the e of this, since this is plus, that's the same thing as e of this times e of this. Because remember, when you multiply, you add the exponents. So by breaking this up, this becomes just 2. And I can bring that out front. And then I just subtract my 3 to the other side and divide by negative, and you get y equal negative 2e raised to the negative sine x plus 3. So let's look at 2013. It says consider this differential equation. Particular solution passes through this point. Write an equation for the line tangent the graph at 1, use the tangent line to approximate f of 1.2. So again, you're just going to plug in and get your slope. Use your slope in your ordered pair, and you end up getting y equal negative 3x plus 3, and you plug in the 1.2, and you get negative 0.6. Part B says find the particular solution that passes through 1, 0. So remember, we are going to separate our variables. So we're going to divide e to the y over, and the x stays here. We're going to integrate. Remember, this is a negative y, so we got to do u negative y du equal negative dy. So we're going to negate with a negative. So here on this side, we're going to use power rule. So we get this. You can divide by the negative number. Then I'm going to plug in e to the 0 equal this. So that's 1 equal 2 minus c, and you get down 1 equals c. I'm going to go back to my point right here and put my c in. I'm going to take the ln of both sides. So I get this, and then I just divide by negative. And there's my answer. So now we can look at the 2010. They give you the differential equation. They ask you to do the slope fields at the points. So again, you're just going to take the points, plug your values, get your slopes, and sketch them. And then it says sketch through 0, negative 1. So if you go 0, negative 1, and you follow, it's just going to be a straight line right there. Now, while the slope field is only drawn at 12 points, is defined at every point in the xy plane. Describe all points for which dy dx equal -1. So you're going to set that equal to -1 and just solve, and you'll get an equation y equal -x minus 1 that'll represent all the points where it equals -1. Part C says find the particular solution where the initial condition is f of 0 equal -2. Again, we're going to separate our variables, so we're going to, if you have dy dx equal this, you just cross multiply, so you get y, x plus 1. So I'm going to do power rule. I'm going to plug in my value that they gave me, which was 0 equal -2. So the x's go away, and 2 equals c. Go back and put that in. Solve it algebraically. And I'm going to use the negative square root when I take the square root of both sides because the point 0, -2 would be in the negative quadrant.